Hello everyone. It's a great honor to have a presentation in this conference. The topic of our presentation is Data Recovery Method for Magnetic Flux Leakage Signals based on Sinc Fucntion for Oil and Gas Pipeline. I'm the presenter Lisha Peng. My research fields are electrical non-destructive testing and signal processing. Now, I'm a postdoctor in Department of Electrical Engineering of Tsinghua University in China. There are 5 parts of our paper. First, the introduction. Pipeline is the key facility of oil and gas transportation. However, the existence of defects may cause the pipeline damage and leakage, or even the environmental pollution and serious security issues. So, the regular defective inspection is necessary to ensure the safe transportation of oil and gas pipeline. Magnetic flux leakage testing, as one of the most commonly used non-destructive testing technologies, is the priority defect testing method for oil and gas pipeline. The magnetic flux leakage signals obtained based on the magnetic sensors can be used to recognize and reconstruct the defects in the pipeline, which is of significance in the MLF field and has been given rise to extensive research. This fault diagnosis research required the MLF signal to be complete, while the data gaps of MLF signals are common phenomenon in the field testing engineering due to the abnormal state of MLF sensors, overrange signals, or detection noise, and so on. Thus, the recovery of the complete MLF signal is necessary for the pipeline safety diagnosis and its defect estimation. So, this paper puts forward a novel MLF data recovery method based on Sinc Fucntion to recover the gap data in oil and gas pipeline MLF testing. First, data description. In the MLF testing, according to the different size of the defect in the pipeline, the defect data can be divided into 2 types: the unimodal defect data and the bimodal defect data. We can call them UDD and BDD for short. Figure 1a and b give the one-channel signal map of UDD and BDD separately, and Figure 1c and d give 2 typical data gap cases on defect data. Because the defect data are the key basis of pipeline fault diagnosis and defect estimation, the lack of defect data will seriously affect the analysis effect of the defects. Thus, it's important to recover the data gaps in defect data, and this paper is devoted to solve this problem. Here, we use the Sinc Fucntion to reconstruct the signal of defect data. Figure A describes the curve of Sinc Fucntion, and then we define another function f, which is obtained by the transformation of Sinc Fucntion. Figure B describes the curve of function f. Compare the defect data and the function signal in the dotted box. We can find that these 2 curves also have a similar change of pattern. Therefore, referred to the Sinc series extension, we regarded function f as a basic function to reconstruct the MLF signal of defect. The MLF signal of each channel in defect data can be recorded in data matrix. According to the reconstruction equation in the last slide, the data matrix C can be expressed in the red dotted box. This figure gives a typical curve of MLF signal of defect with BDD feature and its calculation result by the sum of series basic functions. It can be seen that the calculation curve is very close to the target MLF curve. When we choose the top two ways of the basic function as the sum to calculate the MLF curve, it shows in green line. It also shows a good coincidence with the target MLF curve. So, the MLF signal can be simplified by the following function. Therefore, only these 5 variables are matched. Based on the analysis above, then we can use these 7 steps to recover the data gap of MLF signals of defect. To examine the proposed data recovery method, the MLF experimental study on pipeline defect is performed here. Figure A is the MLF test equipment, and the MLF signal is obtained from the magnetic sensors. Select the complete UDDs and BDDs from test data, and then set the missing gap degree from 4% to 20% respectively. Adopting the proposed method to recover the gap data and the recovery results are shown in the table, which proves the validity of the proposed method. Conclusion. This paper proposed an MLF signal recovery method to solve the data gap problem of defect in oil and gas pipeline MLF testing. By comparing and analyzing the relationship between the Sinc function and MLF signal of defect, we first established series expansion expression based on the Sinc function to describe and calculate the MLF signal of defect. Experiment results verified the validity of the proposed method, and the idea of Sinc function calculation can be further applied to the analysis and reconstruct of MLF signal of defect. Thank you for your attention.